February 20th, 1943, north of Kasserine Pass, Tunisia. The battle report would never capture what German tank commanders witnessed. Through the swirling dust and acrid cordite smoke of the North African battlefield, Hauptmann Klaus Weber pressed his field glasses against the vision port of his Panzer IV. What he observed that morning would haunt German armoured doctrine for the remainder of the war. 5 American Sherman tanks, scattered across broken terrain with no possible line of sight between them, were executing a coordinated assault that defied everything the Wehrmacht understood about armoured tactics. Weber's throat microphone crackled with static as he attempted to contact his company commander. The Fug 5 radio, pride of German engineering just 5 years earlier, delivered nothing but electrical interference that drowned out human voices. Engine noise, track movement, and the electromagnetic chaos of battle rendered his 10-watt amplitude modulation transmitter nearly useless beyond 300 meters. Most of his platoon's tanks carried only receivers, silent metal boxes that could hear orders but never respond. The Americans moved differently. Each Sherman seemed to know exactly where its companions were positioned, anticipating threats from angles no single crew could observe. When Weber's lead tank exposed its flank while maneuvering around a rocky outcrop, an American Sherman, a full kilometer away, immediately shifted position to exploit the vulnerability. No signal flags waved between the enemy vehicles. No dispatch riders raced across the dangerous ground. Yet they functioned as a single organism, each crew aware of tactical developments across the entire engagement. Weber watched in growing alarm as his carefully planned ambush dissolved into chaos. His platoon leader's Panzer IV, easily identified by its multiple radio antennas, became the immediate focus of American attention. 3 Sherman tanks that had been engaging separate targets suddenly concentrated their fire on the command vehicle. The coordination was instantaneous and devastating. Without their leader's radio guidance, Weber's remaining tanks fought as isolated individuals, each crew unaware of threats developing beyond their limited visual range. The contrast in communication capabilities was becoming apparent to German intelligence units monitoring American transmissions. Unlike the static-plagued German amplitude modulation systems, American voices emerged from intercept equipment with startling clarity. Every transmission demonstrated sophisticated coordination between units that should have been operating independently. German signals, analysts noted with growing concern that American tank crews maintained communication at ranges where their own radios produced only noise. Weber's gunner reported movement to the northeast, but without radio contact, Weber couldn't warn adjacent tanks or coordinate a response. He watched helplessly as an American Sherman, guided by information from tanks beyond the ridgeline, positioned itself for a perfect flanking shot against his platoon sergeant's vehicle. The enemy crew had received targeting data from comrades they couldn't see, processed the information, and executed a precise tactical movement while Weber's tanks remained deaf and blind to the developing threat. The technical superiority the Americans demonstrated extended beyond simple communication range. Their frequency modulation technology eliminated the electrical interference that plagued German amplitude modulation systems. While Weber's radio picked up every spark plug firing and every electrical motor as static, American crews enjoyed crystal-clear voice communication even during intense artillery bombardments. The difference was revolutionary, though German commanders didn't yet understand the technological gap they faced. As Weber's Panzer IV reversed frantically behind cover, he observed something that violated basic armoured warfare principles. The American Sherman tanks were spreading across a front of nearly 2 kilometers, yet they maintained perfect tactical coordination. When one tank identified a target, others immediately adjusted their positions to provide supporting fire or block potential escape routes. This level of coordination required communication capabilities that German doctrine assumed were impossible to maintain during mobile operations. The engagement lasted 47 minutes. When German forces finally withdrew, Weber's company had lost 6 tanks while destroying only 2 American Shermans. The kill ratio defied the technical specifications that should have favored German armor and firepower. More disturbing than the tactical defeat was Weber's growing realization that the Americans possessed technological capabilities the Wehrmacht had never anticipated. That evening, Weber's after-action report struggled to explain what his unit had encountered. He described American coordination that seemed supernatural, tank crews who fought with awareness that extended far beyond individual vehicles. His company commander forwarded the report to Division Intelligence with a notation that would prove prophetic. Enemy demonstrates communication capabilities that exceed our current understanding. Recommend immediate technical assessment of American radio equipment. The request would reach German High Command too late to influence the war's outcome. By February 1943, American industry had already produced thousands of SCR-508 radio sets that would transform every Sherman tank into a node in history's first battlefield network. The revolution began 18 months earlier in Galvin Manufacturing Company laboratories, where American engineers solved problems German scientists didn't know existed. July 22, 1941, marked the moment the United States Army standardized Signal Corps radio sets SCR-508, SCR-528, and SCR-538 for all medium tanks. While German panzer divisions advanced through the Soviet Union using tactics dependent on radio communication between command vehicles, American engineers perfected frequency modulation technology that would render German systems obsolete. Daniel E. Noble stood before a blackboard covered with electromagnetic wave equations, explaining to military procurement officers how frequency modulation could revolutionize battlefield communications. The theoretical physicist turned engineer had conceived, applying Edwin Armstrong's FM technology to military vehicles, understanding that armored warfare's harsh electromagnetic environment demanded fundamental departure from amplitude modulation systems. Traditional AM radios treated every electrical discharge as signal interference. FM technology would ignore such interference entirely, delivering clear voice communication during battle chaos. Henryk Magnowski, the principal RF engineer, faced practical challenges of installing sophisticated electronics in a tank's brutal environment. The SCR-508 would function despite temperature extremes, from Arctic cold to desert heat, survive violent mechanical vibration, and maintain frequency stability while subjected to electrical interference from engines, motors, and weapons systems. German engineers chose simplicity over sophistication. American engineers chose complexity that would appear as magic to enemy forces. The BC-604 transmitter represented a quantum leap in military radio technology. Generating 25 watts of power, it delivered 2.5 times the output of Germany's most advanced Fug-5 transmitter. Operating in the 20 to 27.9 MHz frequency range, it provided 10 preset channels with crystal-controlled stability, maintaining precision within 0.01%. German variable capacitor tuning systems drifted constantly off frequency, requiring manual adjustment that tank crews couldn't perform during combat. Magnowski's engineering team solved power management challenges that would plague German radio development throughout the war. The dynamo motor power supply provided stable, filtered electrical power that eliminated interference from the tank's electrical systems. German radios, powered directly from vehicle batteries, picked up every spark plug firing, motor activation, and track movement as static that overwhelmed voice communications. The American solution added weight and complexity, but delivered decisive combat reliability. The dual BC-603 receivers created capabilities that German doctrine considered impossible. Tank commanders could monitor their platoon frequency while simultaneously listening to company command nets, maintaining awareness of tactical developments at multiple organizational levels. This dual-channel capability would allow American forces to coordinate attacks across unit boundaries, while German commanders remained isolated within rigid communication hierarchies. Crystal oscillator technology provided frequency stability that made American coordination possible. Each radio maintained precise frequency alignment, despite combat conditions that would render German variable tuning systems useless. When American tank crews preset their channels before battle, they remained in perfect communication throughout extended engagements. German crews constantly lost contact as their radios drifted off frequency, forcing them to choose between fighting and attempting to re-establish communications. The BC 606 intercom system integrated seamlessly with radio equipment, creating internal communication networks, connecting every crew member to external communications. Tank commanders received threat warnings from gunners, drivers, and loaders who could observe different sectors around the vehicle. Many German tanks lacked intercom systems entirely, forcing crews to communicate through hand signals or shouting over engine noise. American integration created situational awareness that no German tank crew could match. Production specifications revealed the sophistication American industry brought to military radio manufacturing. Each SCR-508 required 2,748 individual components manufactured to exacting tolerances. The BC-604 transmitter alone contained 474 capacitors and 385 resistors, each calibrated for precise electrical characteristics. Crystal oscillators had to maintain frequency stability despite temperature extremes and mechanical vibration that would destroy civilian radio equipment. Throat microphones and noise-cancelling headphones enabled clear voice communication during combat conditions that made conventional microphones useless. Tank crews could coordinate complex maneuvers while their vehicles fired main guns, machine guns, and received incoming artillery. The acoustic engineering represented years of development, anticipating battlefield conditions German designers had never systematically addressed. Weight became a measure of technological advancement. The complete SCR-508 system weighed 181 pounds, nearly twice the weight of German radio equipment. Military procurement officers initially questioned whether tank crews could accommodate such heavy equipment. Noble's team demonstrated that communication advantages justified every pound. A tank with superior communications would defeat a tank with superior armour if engagement lasted long enough for coordination to matter. By December 1941, American tank production lines were installing radio equipment that would transform armoured warfare. Every Sherman tank manufactured would carry communication systems more sophisticated than radios equipping German command vehicles. The electromagnetic revolution was invisible to enemy intelligence, hidden inside steel hulls appearing identical to conventionally equipped tanks. The fundamental difference between German amplitude modulation and American frequency modulation represented more than engineering philosophy. It was the difference between 19th century thinking and 20th century innovation. Edwin Armstrong's FM technology, perfected in 1933 and licensed to the military, eliminated static and interference that plagued every AM system. While German tank crews struggled to hear human voices through electrical noise, American crews enjoyed telephone-quality clarity during armoured combat. Obergefreiter Hans Müller pressed his headphones against his ears, straining to understand orders from his company commander's Panzer IV. The Fug 5 radio's amplitude modulation receiver treated every electrical discharge as legitimate signal, amplifying engine ignition noise, motor sparking, and track friction into overwhelming cacophony. Each time Müller's tank shifted gears, The transmission generated electromagnetic interference that drowned out voice communications. When artillery shells exploded nearby, electrical discharges rendered his radio useless for precious seconds when communication was most critical. 300 meters away, Staff Sergeant Mike Rodriguez adjusted the squelch control on his SCR 508 receiver and heard his platoon leader's voice with startling clarity. Frequency modulation technology ignored electrical interference that would paralyze AM systems. Rodriguez maintained perfect voice contact, while his Sherman's engine ran at maximum RPM, while machine guns fired continuously, and even while receiving direct artillery strikes, generating massive electrical discharges. The FM system's capture effect meant the strongest signal on any frequency dominated completely, eliminating partial reception and static mixing. German radio engineers had made fundamental compromises that seemed logical in 1938, but proved catastrophic by 1943. The Fug 5's 10-watt transmitter represented maximum power that German tank electrical systems could provide reliably. Vehicle alternators generated barely enough electrical power for essential systems, leaving little surplus for radio equipment. Variable capacitor tuning, chosen for simplicity and cost reduction, required constant manual adjustment as components heated and cooled during combat. American engineers solved power generation problems that German designers never adequately addressed. Sherman tanks carried dedicated dynamo generators, specifically designed to power radio equipment with clean, filtered electrical current. The 25-watt BC 604 transmitter drew stable power that remained constant regardless of engine RPM or electrical load from other systems. This power advantage translated directly into communication range that German crews couldn't match. Frequency stability represented another decisive American advantage. Crystal-controlled oscillators maintained precise frequency alignment within 0.01% accuracy, ensuring tank crews remained in perfect contact throughout extended operations. German variable capacitor systems drifted constantly as components expanded and contracted with temperature changes. Tank crews lost communication contact not because of enemy action, but because their radios gradually shifted off frequency during normal operations. The range differential became apparent during first encounters between German and American armored forces. Fug 5 radios achieved maximum range of 2 to 3 kilometers under ideal conditions when tanks remained stationary with engines off. During mobile operations, when tanks moved at combat speeds with all systems operating, effective range dropped to hundreds of meters. Electrical interference generated by moving tanks overwhelmed weak AM signals, creating communication dead zones. American FM radios maintained clear communication at ranges exceeding 7 kilometers during mobile operations. Frequency modulation technology cut through electrical interference like a blade through paper, delivering consistent performance regardless of mechanical or electrical conditions. Tank crews could coordinate complex maneuvers across distances that German doctrine considered impossible for tactical radio communications. The psychological impact of communication reliability affected crew performance in ways military planners hadn't anticipated. German tank crews learned to expect radio failure and developed tactics assuming communication breakdown. They fought as isolated individuals, relying on visual signals and predetermined plans that couldn't adapt to changing conditions. American crews developed confidence, allowing coordination attempts German crews would never risk. Static became the soundtrack of German armored operations. Every radio transmission included background noise that forced crews to concentrate intensely just to understand basic information. Important tactical details were lost in electrical interference, while urgent warnings arrived garbled beyond comprehension. The constant struggle to maintain communication degraded crew effectiveness and increased fatigue during extended operations. American crews experienced radio communication as clear as peacetime telephone calls. Complex tactical instructions transmitted without repetition, detailed target descriptions shared between units, and precise coordination of supporting fires all became routine capabilities that German forces couldn't duplicate. The clarity advantage allowed American tank crews to process information faster and coordinate responses that appeared supernatural to enemies struggling through static. Production statistics revealed American commitment to communication superiority. By 1943, American factories manufactured tank radios with specifications exceeding German equipment in every measurable category. Transmission power, frequency stability, electrical filtering, and mechanical durability all demonstrated technological advantages that would only increase as the war progressed. The electromagnetic spectrum had become a battlefield where German forces fought with obsolete weapons against American technology they didn't understand. Static versus clarity, isolation versus connection. November 8, 1942. Operation Torch brought American armor to North African shores near Safi and Fadala, carrying radio technology that would fundamentally alter the balance of armored warfare. The 2nd Armored Division's Sherman tanks rolled off landing craft equipped with SCR-508 radios that represented 5 years of American technological advancement over anything the Afrika Korps possessed. German intelligence officers, monitoring Allied communications from their positions in Tunisia, were about to discover that their enemy fought with capabilities they had never imagined possible. Oberst Heinrich von Luck, commanding reconnaissance elements of the 21st Panzer Division, received his first intercepts of American tank communications on November 15th. His signals intelligence section reported transmissions with clarity that exceeded German field telephone quality. The intercept operators noted that American tank crews maintained constant voice contact at ranges where German Fug-5 radios produced only static. More disturbing was the realization that every American transmission originated from individual tanks, not just command vehicles. The Afrika Korps operated under communication constraints that had plagued German armored forces since the beginning of the war. A standard German tank platoon of 5 vehicles included only 1 or 2 tanks, equipped with full Fug, 5 transceivers capable of both transmitting and receiving. The remaining tanks carried Fug-2 receivers that could hear orders but couldn't respond or report enemy positions. This communication hierarchy created critical vulnerabilities that American forces would exploit mercilessly. German tank platoons functioned through rigid command structures necessitated by limited communications. The platoon leader transmitted orders that subordinate tanks acknowledged through actions rather than words. When command tanks were destroyed, easily identified by their multiple antennas, entire platoons lost coordination. Tank crews found themselves isolated in individual battles within larger engagements, unable to call for help or warn comrades of developing threats. Lieutenant Colonel William Darby, observing American tank operations during the advance toward Gafsa, noted coordination capabilities that exceeded anything described in pre-war doctrine. Sherman tank crews, separated by broken terrain, maintained perfect tactical awareness through crystal-clear radio communications. Tank commanders could simultaneously monitor platoon and company frequencies, receiving orders while staying informed about broader tactical developments. This dual-channel capability created situational awareness that no German tank crew could match. The vulnerability of German command vehicles became apparent during the first major encounter at Sidi Bouzid. American tank crews, guided by clear radio intelligence, systematically targeted German tanks with multiple antennas. Once command vehicles were eliminated, remaining German tanks operated without coordination, fighting as isolated individuals, while American forces maintained perfect unit cohesion through uninterrupted radio contact. Major Hans Joachim Marseille, temporarily assigned to ground operations after his legendary air combat career, observed German tank tactics from a unique perspective. He noted that Luftwaffe pilots maintained better radio coordination than tank crews, despite operating in three-dimensional combat environments. The contrast highlighted fundamental inadequacies in German armoured communication systems that Air Force technology had already solved. German signals intelligence units struggled to understand the scope of American communication superiority. Intercept reports described coordination between tank units that should have been operating independently. American crews shared targeting information, warned each other of threats, and coordinated supporting fires with precision that German doctrine assumed required visual contact. The electromagnetic signatures indicated that every American tank possessed full transmission capabilities, not just selected command vehicles. The psychological impact on German tank crews was immediate and devastating. They had trained to fight enemies with communication limitations similar to their own. Instead, they faced opponents who seemed to possess supernatural awareness of battlefield developments. American tanks responded instantly to threats reported by other units miles away. Artillery strikes, coordinated through tank radios, arrived within minutes of target identification. The speed of American response suggested communication capabilities that German crews couldn't comprehend. General Lieutenant Erwin Rommel, analyzing early engagements with American forces, attributed their coordination to superior training rather than technology. His intelligence staff reported American radio discipline and communication procedures that appeared to result from extensive peacetime preparation. The fundamental technological gap remained invisible to German commanders who couldn't imagine the communication revolution occurring inside every Sherman tank. Production schedules revealed the magnitude of American commitment to communication superiority. By November 1942, Motorola's Chicago factory was producing SCR 508 radio sets at rates that exceeded total German Fugue 5 production for the entire war. American industrial capacity delivered sophisticated communication equipment to every tank crew, while German forces struggled to equip even command vehicles with adequate radios. The Battle of Kasserine Pass would provide the first major demonstration of this technological disparity. German tactical victory would mask a communication revolution that was already determining the war's ultimate outcome. American tank crews fought with coordination capabilities that German doctrine said were impossible to maintain during mobile armoured operations. February 14th to 24th, 1943. The Battle of Kasserine Pass would be remembered as Germany's last tactical victory in North Africa, but hidden within that triumph lay revelations that shocked Wehrmacht observers. Though German forces successfully penetrated American lines and inflicted heavy casualties, they witnessed coordination capabilities that defied everything they understood about armoured warfare. The scattered elements of the US 1st Armoured Division maintained communication and coordination across 50 miles of chaotic battlefield, demonstrating technological superiority that would haunt German commanders. General Major Heinz Ziegler, commanding the 10th Panzer Division's advance elements, pressed his attack through Fade Pass with growing bewilderment. His intelligence officers had predicted American collapse once their forward positions were overrun, based on German experience with communication breakdown during rapid advances. Instead, American tank crews who had never met were coordinating defensive fires, sharing target information, and warning distant units of German movements with precision that seemed impossible. The morning of February 20th brought the most disturbing revelation. Ziegler's lead companies had penetrated deep into American rear areas, expecting to find isolated tank crews fighting individual battles. Instead, they encountered Sherman tanks that responded instantly to threats developing miles away. American tank commanders received targeting data from units beyond visual range, processed the information, and executed coordinated responses, while German crews remained deaf to developments beyond their immediate vicinity. Hauptmann Werner Schroeff, commanding a company of Panzer IVs in the assault, monitored German radio frequencies with growing frustration. His Fug 5 radio delivered constant static that made voice communication nearly impossible during mobile operations. Engine noise, track movement, and electrical interference overwhelmed the amplitude modulation system's weak signals. When Schroeff attempted to coordinate with adjacent units, he received only fragments of transmissions mixed with electromagnetic noise that rendered tactical information useless. 2 kilometers away, American tank crews enjoyed crystal-clear frequency modulation communications that cut through battlefield chaos like surgical instruments. Staff Sergeant Robert Martinez, commanding a Sherman from the 1st Armored Division's Scattered Combat Command A, maintained perfect voice contact with his platoon leader while receiving updates from company headquarters and warnings from reconnaissance elements operating miles away. The dual-channel capability of his SCR 508 radio created situational awareness that no German tank crew could achieve. German signals intelligence units, monitoring American communications from concealed positions, documented coordination that violated basic principles of armored warfare. Their intercept reports described American tank units maintaining communication at ranges where German radios produced only static. More alarming was the discovery that every American tank appeared capable of full transmission, creating communication redundancy that German forces couldn't match. When American command tanks were destroyed, subordinate crews immediately assumed coordination functions. The psychological impact on German tank crews was immediate and profound. They had trained to exploit communication breakdown during rapid advances, expecting enemy forces to fragment into isolated pockets once their command structure was disrupted. Instead, American units maintained coordination despite being scattered across vast areas of broken terrain. Sherman tank crews, who had lost visual contact with their parent units, continued fighting as integral parts of larger tactical plans. Oberst Rudolf Siakinius, analyzing intercepts from his signals intelligence section, noted American communication procedures that exceeded anything in German doctrine. American tank commanders shared detailed target descriptions, coordinated complex maneuvers across unit boundaries, and directed supporting artillery fires through radio networks that remained functional despite intense combat conditions. The clarity and reliability of American transmissions suggested technological capabilities that German intelligence had never suspected. The contrast in communication reliability became apparent during the climactic fighting around Jebel Lasuda. German tank platoons, separated by rocky terrain that blocked visual signals, lost coordination when their single command vehicle was destroyed by American artillery directed through radio communications. The remaining German tanks fought as isolated individuals, while American forces, despite being tactically defeated, maintained unit cohesion through uninterrupted radio contact that allowed coordinated withdrawal and regrouping. Major General Lloyd Fredendall's tactical failures during the battle masked the communication revolution occurring within his armoured units. Though American forces suffered tactical defeat, their radio coordination capabilities demonstrated technological superiority that German commanders couldn't comprehend. Individual Sherman tank crews, cut off from their parent units, continued receiving intelligence updates, fire support coordination, and tactical guidance through radio networks that functioned despite command structure disruption. The German 10th Panzer Division's intelligence section filed reports that would prove prophetic. Their assessment noted American coordination capabilities that exceeded German understanding of battlefield communications. The report stated, enemy tank units demonstrate communication reliability and range that suggests technological advancement beyond current German capabilities. By February 1943, American production lines were delivering thousands of SCR 508 radio sets, that would transform every Sherman tank into a node in history's first battlefield network. Kasserine Pass had been Germany's last tactical victory, but it revealed American technological superiority that would determine the war's outcome. September 1943 to June 1944, American armor entered the mountains of Italy, where terrain should have negated radio advantages, but frequency modulation technology proved even more valuable in conditions that rendered German amplitude modulation systems completely useless. The SCR-508's ability to handle multipath interference of mountain valleys far exceeded anything German engineers had anticipated. Sherman tank crews coordinated movements through terrain where visual signals were impossible and German radios failed entirely. During the advance toward Cassino, American armored units demonstrated capabilities that defied German understanding of mountain warfare. Tank platoons, separated by ridgelines, coordinated attacks with precision that German doctrine said required visual contact. The 1st Armored Division's after-action reports described routine coordination at distances where German radios produced only static, while American crews maintained crystal-clear communications through valleys that should have blocked all radio transmissions. The limitation that would prove nearly fatal emerged during the Normandy landings. Sherman tank radios couldn't communicate with infantry radios operating on different frequencies. The infantry's SCR-300 operated on 40 to 48 MHz, incompatible with tanks' 20 to 27.9 MHz range. This communication gap proved deadly in the bocage, where German infantry with Panzerfausts could approach American tanks while nearby American infantry had no way to warn them. Sergeant First Class Tommy Rodriguez crouched behind a stone wall in the Norman hedgerows, watching German infantry creeping toward his supporting Sherman tank through dense vegetation that blocked visual contact. His SCR-300 radio maintained perfect contact with his squad and platoon, but he couldn't warn the tank crew of the approaching threat. The frequency incompatibility meant that tank and infantry forces fought parallel battles without communication, integration that modern combined arms required. Lieutenant Bob Harrison, commanding the threatened Sherman, monitored his SCR-508 radio for reports from other tank crews while remaining completely unaware of infantry movements developing within 50 meters of his position. His radio provided perfect coordination with other armored vehicles across miles of battlefield, but the frequency gap left him blind to threats that foot soldiers could observe clearly. The technological revolution that connected every tank had created a communication void between tanks and infantry. American innovation solved the problem within weeks of recognizing its scope. Tank crews mounted EE-8 field telephones in ammunition boxes, welded to tank exteriors, wired directly to internal communications systems. Infantry soldiers could physically connect their telephone handsets to tanks, creating instant voice communication that bridged the frequency gap. The modification required no sophisticated engineering, just American pragmatism applied to battlefield problems that doctrine hadn't anticipated. By Operation Cobra in late July 1944, this simple modification had revolutionized tank infantry cooperation. Private First Class Jimmy O'Brien, advancing through the hedgerows with the 4th Infantry Division, carried an EE-8 handset that connected directly to supporting Sherman tanks. When he spotted German machine gun positions that tanks couldn't see, he plugged into the external telephone jack and provided targeting information as precise as artillery forward observers. The psychological impact on German defenders was profound and demoralizing. They faced American forces that seemed to possess supernatural awareness of battlefield developments. Tank crews received instant warnings from infantry scouts, while infantry units coordinated with tank support through communication links that German forces couldn't intercept or disrupt. The speed and precision of American combined arms coordination suggested technological integration that German commanders couldn't comprehend. Obergefreiter Klaus Richter, defending a hedgerow position near Saint-Vith, observed American coordination that violated everything he understood about battlefield communications. American infantry spotted his machine gun position and within minutes directed accurate tank fire through communication methods his intelligence training hadn't covered. The Americans seemed to fight with technological advantages that made German defensive positions transparent to enemy observation and fires. The contrast with German capabilities was stark and discouraging. German tank crews remained isolated from infantry support by communication barriers that technology couldn't bridge. Panzer commanders fought without infantry intelligence, while German foot soldiers couldn't direct tank support through any reliable communication method. Visual signals remained the primary coordination method, requiring dangerous exposure that American forces could exploit through superior communication-directed fires. July 25th to 30th, 1944, Operation Cobra demonstrated the full potential of American communication integration. The 2nd Armored Division, commanded by Major General Edward Brooks, coordinated over 200 Sherman tanks through radio networks, while maintaining infantry coordination through telephone connections that enabled unprecedented battlefield control. German defenders from Panzer Lehr Division faced an enemy that possessed integrated communication systems, connecting every American unit in ways German doctrine had never imagined. The modification that solved tank infantry communication represented American problem-solving at its most effective. Simple technology, applied intelligently, had eliminated a critical vulnerability while creating tactical advantages that German forces couldn't duplicate. The electromagnetic revolution was expanding beyond tank-to-tank coordination to encompass combined arms integration that would define modern warfare. July 25th to 30th, 1944. Operation Cobra unleashed the full devastating potential of American radio superiority as Major General Edward H. Brooks commanded over 200 Sherman tanks through radio networks that enabled battlefield control beyond anything German commanders had imagined possible. The 2nd Armored Division's coordination capabilities created what appeared to German observers as supernatural awareness, with tank crews responding instantly to threats reported by units miles away and artillery strikes arriving within minutes through radio-coordinated fires. General Major Fritz Bayerlein, commanding Panzer Lehr Division, watched his elite formation disintegrate under American coordination that defied every principle of armored warfare he understood. His division, once Germany's premier training unit, equipped with the most experienced tank crews in the Wehrmacht, had been reduced to communication poverty that rendered sophisticated tactics impossible. Most of his tanks operated without radios, depending on visual signals in terrain where visibility rarely exceeded 100 meters. The few functioning German radios suffered from interference and limited range that prevented effective coordination during mobile operations. Bayerlein's command tank could barely maintain contact with his battalion commanders, while American tank platoons coordinated effortlessly across distances that German doctrine considered impossible for tactical radio communications. The contrast was not just technological, but philosophical, revealing fundamental differences in how the two armies conceived modern armoured warfare. Staff Sergeant Mike O'Malley, commanding a Sherman from Combat Command A, monitored multiple radio frequencies simultaneously while manoeuvring through bocage terrain that should have isolated his tank from supporting units. His SCR 508 radio maintained crystal-clear contact with his platoon leader while receiving intelligence updates from reconnaissance elements operating 3 miles ahead. When German Panther tanks were reported moving toward his sector, O'Malley received targeting information and coordinated responses before enemy forces appeared in visual range. The irony was profound and painful for for German observers who understood military history. Germany had pioneered radio use in armoured warfare under Heinz Guderian, the architect of Blitzkrieg, who had insisted on radio equipment in tanks since the 1920s. His book, Achtung Panzer, published in 1937, emphasized communication as essential to armoured operations. Guderian had developed radio communication systems that enabled Wehrmacht victories in Poland, France, and the early Soviet campaigns. Yet by 1944, German tank production couldn't provide the radios that Guderian's own doctrine demanded. The man who had written the principles of modern armoured warfare watched his communication philosophy implemented more effectively by enemy forces than by his own army. American industry had achieved what German doctrine required, but German production couldn't deliver: universal radio deployment that connected every tank crew in seamless communication networks. Production statistics revealed the crisis that German commanders couldn't solve through tactical innovation. In 1943, Germany manufactured approximately 5,700 medium tanks, but fewer than 2,000 Fug transceivers. Many radios went to command vehicles and assault guns, leaving regular tank units desperately short of communication equipment that doctrine said was essential. Meanwhile, American factories achieved what German industry couldn't match. Every Sherman tank manufactured received sophisticated radio equipment that exceeded the capabilities of German command vehicles. The contrast in industrial priorities revealed strategic thinking that would determine the war's outcome. America had chosen to build adequate tanks with superior communications, while Germany built superior tanks that fought as isolated individuals. Hauptmann Joseph Priller, commanding a company of Panzer IVs during the Cobra fighting, experienced the isolation that characterized German armoured operations. His radio-equipped command tank could barely maintain contact with his platoon leaders, while American voices filled the electromagnetic spectrum with coordination that seemed to come from everywhere at once. American tank crews shared targeting information, warned each other of threats, and directed supporting fires with precision that Priller's unit couldn't duplicate. The psychological warfare aspect of superior communications created advantages that transcended tactical coordination. German tank crews fought with the knowledge that they were alone, isolated within steel hulls that couldn't call for help or warn comrades of developing threats. American crews fought with confidence that came from knowing they were never alone, always connected through radio waves to supporting units that could provide assistance within minutes. Weather conditions that should have equalized communication capabilities instead amplified American advantages. Rain and fog that interfered with visual signals had no effect on frequency modulation radios that cut through atmospheric conditions like knives through paper. German amplitude modulation systems, already hampered by electrical interference, became completely unreliable during storms that left American crews with perfect communications. The collapse of Panzer Lehr Division during Operation Cobra demonstrated what happened when superior individual platforms met inferior communication systems. German tanks with better armor and more powerful guns were systematically destroyed by American forces, whose coordination advantages overcame technical deficiencies. The network had defeated the platform, exactly as American engineers had intended. The production miracle unfolding in Motorola's Chicago factory represented American industrial mobilization at its absolute peak. Before the war, the company had manufactured car radios for civilian markets, but converting to military production required complete retooling and solving unprecedented technical challenges. Each SCR 508 required 2,748 individual components manufactured to exacting military standards that exceeded anything in civilian electronics. The BC 604 transmitter alone contained 474 capacitors and 385 resistors, each calibrated for precise electrical characteristics. Crystal oscillators had to maintain frequency stability despite temperature extremes, ranging from Arctic cold to desert heat and mechanical vibration that would destroy civilian radio equipment. The manufacturing complexity represented American industrial capabilities that no enemy nation could replicate, even if they had understood the technological principles involved. Production statistics told the story of American commitment to communication superiority that would determine the war's outcome. 1942 brought 3,800 SCR 508 family radios rolling off American assembly lines. By 1943, production had increased to 11,400 units as factories hit their stride and supply chains optimized for military requirements. 1944 saw 24,000 units produced, representing the peak of American radio manufacturing capability. Total wartime production exceeded 50,000 tank radio sets, ensuring that all 49,324 Sherman tanks manufactured during the war received sophisticated radio equipment. The contrast with German production revealed strategic priorities that would prove decisive. Germany manufactured approximately 5,700 medium tanks in 1943, but fewer than 6,000 Fug-5 transceivers during the entire war. The mathematics were stark and unforgiving. American industry achieved 100% radio deployment, while German forces struggled to equip 20% of their tanks with full communication capabilities. Most German tanks entered combat with receivers only, unable to transmit reports or call for assistance. Walter Dornberger, observing German production limitations from his position in the weapons development bureaucracy, noted the impossible choices facing German industry. Every sophisticated Fug-5 transceiver required resources that could produce multiple simpler receivers. German commanders chose quantity over capability, fielding more tanks with limited communications rather than fewer tanks with full radio systems. The decision reflected resource constraints that American industry never faced. Soviet tank forces suffered even worse communication poverty, despite producing more tanks than any other nation. The T-34, despite being the most produced Allied tank, with over 84,000 manufactured, typically entered combat without any radio equipment. Soviet doctrine relied on flag signals and pre-battle planning with catastrophic results against German forces in 1941. By 1943, Lend-Lease provided some relief to Soviet armored forces. American radios, including SCR-508 sets, equipped Soviet command tanks and created islands of communication capability within formations that remained largely silent. Even by war's end, only about 25% of Soviet tanks carried radios of any type. The comparison highlighted American achievement in universal deployment that no other nation approached. Meanwhile, American factories solved manufacturing challenges that revealed the sophistication required for military radio production. Each BC-604 transmitter required precision wiring that connected hundreds of components in exact configurations. Quality control procedures tested every radio set under simulated combat conditions, including temperature cycling, vibration testing, and electrical interference simulation. Rejection rates for defective equipment remained below 2%, demonstrating manufacturing excellence that military operations demanded. The human cost of German communication poverty became apparent through after-action reports that described isolation and coordination failures. Tank crews fought individual battles within larger engagements, unable to warn comrades or call for support when overwhelmed by superior forces. German tactical excellence at the crew level couldn't compensate for systemic communication failures that prevented effective coordination above the individual tank level. American crews experienced the opposite psychological environment. They fought with confidence that came from knowing that help was always available through radio calls that would bring immediate assistance. Tank commanders could request artillery support, airstrikes, or reinforcements through communication systems that functioned reliably under all combat conditions. The psychological advantage of connection versus isolation affected crew performance in ways that training could never address. Production scheduling revealed American industrial planning that anticipated communication requirements years before they became tactically critical. Radio manufacturing began increasing in 1941 before America entered the war, based on observations of German success with radio-coordinated armored operations. American planners understood that communication superiority would determine armored warfare outcomes and committed industrial resources accordingly. The electromagnetic revolution was becoming an industrial revolution that transformed American manufacturing capabilities. Companies that had never built military equipment mastered sophisticated radio production techniques that required precision manufacturing beyond civilian standards. By 1944, American radio production exceeded the combined output of all enemy nations while maintaining quality standards that ensured reliable performance under combat conditions. March to April 1945. As American forces approached the Rhine River, their communication superiority reached its absolute zenith, creating tactical advantages that rendered German defensive preparations meaningless. The capture of the Ludendorff Bridge at Remagen demonstrated the devastating speed of American command and control systems that functioned faster than German forces could respond. When the 9th Armoured Division discovered the bridge intact at 14:30 hours on March 7th, radio reports reached 1st Army headquarters within minutes, triggering coordinated responses across the entire Western Front. Within 1 hour of the initial radio transmission, divisions across hundreds of miles of front were shifting to exploit the unexpected opportunity. Tank battalions received new orders through SCR 508 radios that maintained perfect clarity despite the electromagnetic chaos of massive troop movements. Artillery units repositioned to support the bridgehead through radio coordination that German telephone-dependent command systems couldn't match. The speed of American reaction demonstrated communication capabilities that German commanders had never imagined possible. Field Marshal Gerd von Rundstedt, commanding Army Group West, learned of the Remagen crossing through telephone reports that arrived hours after American radio networks had already coordinated the exploitation. German forces, dependent on landline communications that American aircraft systematically destroyed, couldn't respond with comparable speed to tactical developments that required immediate reaction. The communication time differential, measured in hours, created tactical advantages that no amount of German fighting skill could overcome. Major General John Leonard, commanding the 9th Armoured Division's Combat Command B, established radio contact with supporting units before his lead tanks had completely crossed the bridge. His SCR 508 equipped command tank became the nerve center for coordination that integrated artillery fires, air support, and reinforcement schedules through radio networks that functioned despite German artillery attempting to destroy the crossing site. American radio coordination created an impenetrable defense of the bridgehead that German counterattacks couldn't penetrate. Tank platoons from different battalions integrated seamlessly into the bridgehead defense, coordinating fires through radio networks that eliminated the confusion typically associated with ad hoc task force operations. German counterattacks, poorly coordinated due to communication failures, arrived piecemeal and were destroyed in detail by American forces that maintained perfect situational awareness through radio intelligence that provided advance warning of every German movement. The German 11th Panzer Division, assigned to eliminate the Remagen bridgehead, discovered that their communication systems had collapsed under the pressure of rapid redeployment. Radio equipment that functioned adequately during static defensive operations failed completely when subjected to electromagnetic interference and mechanical stress of rapid movement. Tank crews lost contact with their commanders. Artillery units couldn't coordinate with attacking forces, and infantry support disappeared into communication voids. Oberst Hans von Luck, commanding elements of the 21st Panzer Division during the final campaigns, wrote about the communication isolation that characterized German armored operations during the war's final months. His tank crews fought individual battles without coordination, unable to warn each other of threats or coordinate mutual support. The contrast with American capabilities was stark and demoralizing for crews who understood they were fighting a technologically superior enemy. April 1945 brought the encirclement of the Ruhr Pocket, demonstrating the culmination of American communication superiority in a complex double envelopment that required coordination between 1st and 9th Armies across hundreds of miles of front. American armored columns coordinated their movements entirely through radio communications that maintained perfect contact despite operating in heavily industrialized terrain that should have blocked radio transmissions. Inside the pocket, 325,000 German troops found themselves trapped partly because their communications had collapsed under American electronic warfare and systematic destruction of telephone infrastructure. American fighter bombers, guided by radio-equipped forward air controllers, systematically destroyed German communication nodes while leaving their own radio networks untouched. Wehrmacht units lost contact with higher headquarters and each other, creating tactical paralysis. Field Marshal Walter Model's final radio transmissions before communication failure revealed the German plight that American radio superiority had created. His desperate messages described complete loss of contact with subordinate units, inability to coordinate defensive operations, and tactical situations that changed faster than broken communication systems could report. The electromagnetic revolution had created German command isolation that made effective resistance impossible. American tank crews fighting within the Ruhr Pocket maintained radio contact with units operating dozens of miles away, creating coordination capabilities that German forces couldn't match at the company level. Tank commanders received intelligence updates about German movements, artillery support coordination, and tactical guidance through radio networks that functioned despite industrial electromagnetic interference that would have paralyzed German communication systems. By April 1945, American radio superiority had created tactical conditions where German resistance became tactically meaningless regardless of individual courage or defensive skill. The electromagnetic revolution had determined the war's outcome more decisively than any advantage in armor, firepower, or numbers. The war's end brought American technical intelligence teams to evaluate German equipment, confirming what combat experience had already demonstrated. U.S. Army Technical Intelligence Report number 176 delivered a devastating assessment of German tank communications equipment, concluding that it was approximately 5 years behind American systems in every measurable category. The absence of frequency modulation, limited radio distribution, and poor electrical suppression had created critical vulnerabilities that American forces exploited throughout the European campaign. Soviet evaluators, given access to captured German equipment through Allied cooperation, reached identical conclusions. The Red Army, despite producing more tanks than any other nation, chose to copy American radio designs rather than German systems for post-war development. Soviet engineers understood that communication superiority had determined armored warfare outcomes more decisively than platform advantages, and they prioritized American frequency modulation technology for future tank production. The statistics of technological disparity told the complete story of electromagnetic revolution that had changed warfare forever. American radio production exceeded 50,000 SCR 508 family units that equipped every Sherman tank with communication capabilities more sophisticated than German command vehicles. German production managed only 6,000 Fug 5 transceivers during the entire war, creating a deployment rate of approximately 20% for full communication systems. Transmission power revealed the fundamental gap that German forces never closed. American BC 604 transmitters generated 25 watts of clean, filtered power that maintained communication at ranges exceeding 7 miles during mobile operations. German Fug 5 systems, limited to 10 watts of unfiltered power, achieved maximum range of 2 to 3 miles under ideal conditions and mere hundreds of meters during combat operations, when electrical interference overwhelmed their amplitude modulation receivers. Frequency stability demonstrated American engineering superiority that created reliable coordination impossible with German equipment. Crystal-controlled oscillators maintained precision within 0.01% accuracy, ensuring that American tank crews remained in perfect contact throughout extended operations. German variable capacitor systems drifted constantly with temperature changes, forcing crews to choose between fighting effectively and maintaining communications that gradually became unusable during normal operations. Communication effectiveness measurements revealed tactical advantages that no individual superiority could overcome. American fire missions averaged 3 to 5 minutes from target identification to artillery impact through radio coordination that functioned reliably under all combat conditions. German fire missions required 15 to 30 minutes when communication functioned at all, creating response times that allowed enemy forces to relocate before supporting fires arrived. The psychological impact of communication, isolation versus connection had affected every level of German armoured operations. Tank crews learned to expect radio failure and developed tactics that assumed communication breakdown, fighting as isolated individuals rather than coordinated teams. American crews developed confidence that came from knowing they were never alone, always connected through radio waves to supporting units that could provide immediate assistance. Modern conflicts validated the lessons that World War II had demonstrated with brutal clarity. The 1991 Gulf War saw coalition forces with superior communications systematically destroy Iraqi forces equipped with individually superior Soviet-designed tanks but inferior radio systems. Network-centric warfare defeated platform-centric warfare exactly as American engineers had predicted when they designed the SCR-508 radio system. The 2003 invasion of Iraq again demonstrated that communication superiority determined outcomes more decisively than individual platform advantages. American forces destroyed Iraqi resistance through coordination capabilities that connected every combat unit in integrated networks that enemy forces couldn't match or counter. The electromagnetic revolution that began in 1942 continued determining military outcomes. German military leaders, rebuilding their forces in the 1950s, prioritized communications based on World War II lessons that defeat had taught them. Every Leopard tank manufactured carried comprehensive radio systems that reflected understanding of communication requirements that wartime experience had demonstrated. A Bundeswehr training manual explicitly stated that the defeat of superior German tanks by inferior American vehicles with superior radios taught that information dominance outweighs platform superiority. Field Marshal Wilhelm Keitel's reported comment at Germany's surrender captured the fundamental truth that the war had revealed. Whether accurately quoted or apocryphal, his statement that "we knew how to build better tanks, but you knew how to make them work together," identified the technological gap that had determined the conflict's outcome. America had built not just 49,324 Sherman tanks, but 49,324 nodes in history's first armoured battlefield network. The revolution in military affairs that historians identify with modern network-centric warfare actually began in 1942, when the first Sherman tank with an SCR-508 radio entered combat. From that moment, warfare changed forever. The side with superior communications defeats the side with superior weapons. The network defeats the platform. The connected overcome the isolated. The Sherman tank's radio superiority had changed warfare forever.